As you said, Sam, it's been, I think, a very good year with exciting new work that has actually been very impactful and that shifted the field in many directions. And so I'm going to mention maybe three highlights that I have noticed being extremely important in the last year. And first, I'm gonna start perhaps with graphics, which is not exactly within computer vision, but very nicely tied to it, and the explosion of NeRFs. So NeRF, which stands for neural radiance fields, um, have had a tremendous impact in computer vision, 3D, and graphics. It's a wonderful work, simple, that has unlocked something that graphics people have actually been working for quite a while. And the innovation there has been a lot with introducing implicit functions and volumetric rendering. And the
Mm.
goal is to reconstruct photorealistically a scene from a few images. Well, a few is actually a little under estimated. It's actually 100 or 200 images, so it's still a
Okay.
lot of images. But the effect is that you can photorealistically synthesize the scene from any viewpoint given these 200 images.
I just wanted to jump in and make sure I'm understanding. The idea is that you've got some 3D scene and you're not building it up from kind of a CAD system or a graphics tool or something like that. Rather, you collect just pictures of the scene from various angles, and through the NeRF process, you're able to create a 3D model of the scene.
So correct. So you basically take so let's say you have a scene. Let's say your room right there, and
Hmm.
so what you will do is that you will go around and collect many images. It actually works well when it's 360 views. So let's say you have a little scene at a center of the room, and you just take pictures around it.
Okay.
Um, and of course, this is going to be your own pictures, so they're going to be from discrete set of viewpoints. So what NeRF will do is that it will take these images, it will try to extract the camera poses. This is going to happen offline, so with systems like ColMap, which have now been very well established, and having posed images of that scene, it will try to reconstruct a 3D representation. Now, that 3D representation is not explicit, so you can't really it's not a mesh or a voxel. It's an implicit representation, and all it does is that it allows you to shoot rays and then project those rays back from a novel viewpoint. So now you are building the system that can not only understand the scene from the discrete viewpoints that you collected with your photo, with your camera, but it will allow you to reconstruct the scene from novel viewpoints outside of the existing ones. And it does that by maintaining, the photorealism and the detail of the scene that you're capturing.
And so you that the N in NeRF is for neural. Is it a deep learning based technique?
Yeah, so the authors there use a sequence of linear, actually perceptrons. So it's an MLP.
Okay.
So you have a little neural network that maps a 3D point, XYZ, and a direction to color, RGB, and density. The density is the occupancy, basically, whether that point is occupied by the scene or not, or it's empty
Hmm.
space. That this is all that it's doing, and with this information, you're able to um, collect that on array. So array is a collection of 3D points, um, and render that from a novel viewpoint.
Got it. And so, how is this a technique that originated this past year in 2021, or is it a technique that kind of found its voice from prior years?
Yeah, I mean, I think that the work came out in 2020.
Okay.
Of course, this is something that we need all to realize that nothing actually comes, g- gets to life out of nowhere. So,
Yeah.
of course, it's based on previous work. Of course, it's motivated by previous works. I think that where this work has actually innovated is this using this implicit functions along with volumetric rendering. And it has since actually created a huge impact because, of course, it was the first paper came in 2020, but there's a lot of things to fix. How can you do this with fewer reviews? How can you do this faster? How can you do this
Mm.
by consuming less memory? So it has actually created a lot of follow-up works and step-by-step improving this method. Even as we speak, there is like tons of papers coming out even on a daily basis.
Are we seeing its impact primarily in terms of academic papers, or is it something that we've already seen implemented in different applications?
Yeah, that's so. I think that for now, I am. I definitely believe that it is mostly focused on for research, especially while the community tries to improve it, make it more, user friendly, but also, have it consume less memory or and faster. But I do believe that we will see uh, nerves will revolutionize the rendering. So any applications that now involves rendering, I believe, will move into nerves very fast. But I'm talking about Hollywood, visual effects, making movies. I'm talking about the gaming industry, like video games. I think they will also move towards something like a neural representation for rendering. And the reason for that is, I think, very simple. It's so the method is simple. It does require a little bit of our expertise, and so we might actually see a shift of sort of what knowledge you will need in order to make this happen. But it is a lot easier to adapt to new scenes. So you need to do less work. If you want to do, move to different scenes faster. So I do think that it will actually have a tremendous impact. Not now, but in 5 years, maybe if we do this podcast again, we can revisit that question.
And when I think of of rendering, one of the things that I think about is in the case of games, like rendering like from light sources and things like that, is the idea that this NeRF method solves this particular problem of reconstructing the scene from images, or that the techniques that were developed for that problem also have implication in kind of the broader, more broadly in graphics and in rendering, like point source rendering, that kind of thing.
Yeah, I mean, I think they do. I think they definitely are. Have We're seeing more and more. Actually, we're seeing the impact of nerve expanding, very much so, moving beyond. That initial application that we've seen, and we are now seeing how they can incorporate even dynamic scenes, like moving scenes. We are also seeing how to change lighting, how to change materials. We're also seeing how you can hallucinate with them. So the field is ever expanding. So this is why it's an exciting field to be in. I'm sure graphics people are very thrilled because there's a lot of work to do. So yeah, I feel that we haven't even seen the full impact of nerves yet and what they can do. But what
Right.
we know is that the representation is powerful. We know the volumetric rendering is impactful. So the combination of these two ideas, I think, will lead to a lot more innovation.